This assessment asks us which SN2 reaction we would expect to proceed at a more rapid rate, and to justify those results on a reaction coordinate diagram. So we've gone ahead and identified the difference between the two. In this case, we have a primary alkyl halide. In this case, we have a secondary alkyl halide. Everything else is the same. The SN2 reaction is a concerted reaction where the nucleophile donates a pair of electrons to sigma star at the same time that the leaving group leaves. Well, when we look at the difference between primary and secondary, there's going to be less steric hindrance around sigma star in the primary than there is in the secondary. And so we would expect the primary to be the faster reaction. How can we show that? Well, we can illustrate that. We'll do our primary in green. This is going to be a favorable reaction, and we'll assume a transition state that looks something like this, where this is the activation energy. Again, this is for the primary alkyl halide. If we do the same thing for secondary, one of the approximations we're going to do is we're going to have it start at the same point, but as that electron pair approaches sigma star, there's going to be significantly more steric hindrance. That's going to result in a higher transition state energy. And so maybe exaggerated a little bit, it might look something like that. Again, we're still going to assume that it starts and finishes at the same place. If that's not exactly true, it's close enough. But the higher transition state energy as a result of that steric hindrance will allow the secondary reaction, again in orange, to have a higher activation energy and therefore be a slower reaction.